Hi and welcome back. This is Miss Glink, and for this video we're going to talk about how to convert or change, means the same thing, in between mixed numbers and fractions greater than 1. So just remember, fraction greater than 1 is the same as an improper fraction. It's just a different way of saying it. So the first thing I want to show you is how to convert or change from a mixed number to a fraction greater than 1. So if we have 1 and 1/2 and we want to convert it to a fraction greater than 1, the first thing that I do is I focus on my whole number and my denominator. So I'm going to take those two numbers and multiply them. 1 times 2 is 2. And when I'm done with that, I take and I add my 1. So I'm going to take my 2 from here, add 1, and I get 3. So that becomes my new numerator. And the cool thing about the denominator is you can just slide it right over, and because the total number of pieces in the whole really doesn't change. And just so you have a little bit of background, this 1 from the numerator, from our mixed number, really basically acts like it's basically our remainder, because remember, when you're dealing with fractions, really you're dealing with division problems. So we'll get more into that when we go from improper fractions to mixed numbers. So let's just look at another kind of problem like this. If you have 3 2/3 and you want to convert it into a fraction that's greater than 1, you're going to take your whole number of 3, multiply it by 3. So 3 times 3 equals 9. And then you're going to add your 2, or, in other words, your numerator. So I'm going to add it to my 9. So I'm going to take 9 plus 2, and I get 11. That becomes my new numerator. The 3 takes a nice little trek over to here. We still have a 3 as a denominator. The total number of pieces in the whole have not changed. So I think it's important that you not only see the process, but I'll show you what it looks like visually. So first of all, we're going to convert. We'll do 4 and let's do 4 and 2/3. So 4 and 2/3, again, you take your whole number times your denominator. 4 times 3 gives you 12. And then you add your numerator. So 12 plus 2 gives me 14. So I have a numerator of 14. The 3 from the original mixed number slides over, and it still remains a 3. So, like I said, I want you to see what this looks like visually. So, based on this fraction right here, I know that the total number of pieces I need to divide this into would be 3. So if I'm using squares, I know I need to divide each of these squares into 3 pieces because this denominator really tells us how many pieces are going to be in our whole. And as we know, if we have a denominator of 3, that means 3/3 in this case would be equivalent to 1 whole. So I'm going to split all of these into thirds. That one doesn't look very great, but that's okay. We're not looking for perfection. Here's my 4 wholes. But I also know I need to have another one because I have 2/3. So I'm going to draw this one right here. And I'm going to grab another color. So 4 wholes. That means I have to have all 3 of these pieces in the whole had to be shaded in to make a whole. So this is 1 whole plus 1 whole plus 1 whole plus 1 whole, which gives me 4. This is 4 wholes plus this 2/3. So we have 1 2/3. Now check this out. Do you remember? This is the same as 14/3. So let's just see if this works. Let's count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How cool is that? We have 14 pieces of the whole, which is the same as 14/3. So this is a way you can see visually. Oh, and I forgot to put over on this fraction, this is representing 2/3. This is how you can see visually why 4 2/3 is the same as 14/3. So the other part of this video is now we need to convert a fraction greater than 1 to a mixed number. So if you have the fraction or greater than 1 of 3/2, what we want to do, this is just one strategy. We want to focus on this denominator and find multiples, enough of them to get as close to our numerator as possible. For example, I'm going to write my multiples of 2 until I can get, oh, you know what? I have to stop here because we can't get a number that's greater than the 3. 4 is greater than 3. So I'm going to get rid of it. Looks like we can only stick with this one right here. So it took me one multiple of 2 to get here. So I can only skip count by 2's one time to get as close to 3 as possible. Well, that can't be it because we still are not hitting 3. So what we do, we left off on 2. 2 is the closest we could get. So basically, I had to figure out 2 plus what can get me to hit 3. Well, if I count up to 3, it only took one time. I only had to add 1 to get to 3. So that would be our numerator. This is basically like our remainder. So that's why it's a 1. And our denominator can just simply slide over. So this is equivalent to 1 1/2. So let's try this on another problem. If we have the fraction greater than 1 of 6/4, I'm going to try this strategy again. I'm going to skip count, find my multiples of 4 until I can get as close to 6 as possible. So we have 4, 8. Okay, so 8's too high. 4 is as close to 6 as I can get. Again, that's only one multiple. So it took one group of 4 to get as close to 6 as possible without going over. So if we're at 4 right now, but we need to get to 6. So we need to figure out 4 plus what gives me 6. Well, if I count up, 4 plus 2 gives me 6. So that would be my numerator. Move my 4 over. I have 1 2/4. So I'm going to show you what it looks like without having a number that only takes one multiple to get to. So if I have, let's say, 13 thirds, I want to convert it to a mixed number. I'll take my denominator. Let's skip count until we can get as close to 13 as possible. So 3, 6, 9, 12, 15. Okay, so 15 is too high because we need to get as close to 13 as possible. So I'm going to get rid of 15. So now, let's count it. So this is 1, 2, 3. So it takes 4 whole numbers, 4 whole 3s to get as close to 13 as possible. But we still need to find out what number goes here. If we left off on 12 and we want to get to 13, well, 12 plus what gives me 13? Yep, 12 plus 1 gives me 13. And then my 3 just simply slides over. And 13 thirds is the same as 4 1/3. So I want to show you just one more that takes multiple numbers to get to. If I have 17 fourths, I'm going to write my skip counts of 4 for my multiples of 4, 12, 16, 20. Okay, so that means 20 is too high. So 1, 2, 3, 4. So it takes 4 multiples of 4 to get as close as we can to 17. And so 16 is as close as we can get. We have to think 16 plus what gives me 17, and that's 1. So 4 1/4.